Hello everyone, Java 24 is finally here and it brings a total of 24 new features. But don't worry, you don't need to read long documents. I'll quickly walk you through all 24 features, give you a deep dive into the most useful ones with real code, and explain why they matter to Java developers like you. By the end of this video, you will exactly know what's new, what's changing, and how it impacts your Java projects. So let's get started. In this video, I will break down the most impactful updates offered by Java 24 and will give you live examples. So the first feature that I'm going to talk about is nothing but simple source files and instance main methods. It is covered under Java Enhancement Proposal 495. So some background about this feature is Java has often been criticized for requiring too much boilerplate code, but over time, Java has introduced improvements to make coding simpler and more concise. And with simple source files and instance main methods, Java takes another step towards making code more concise and developer friendly. Let's consider the classic Hello World example. This is the simple program where Java 24 features demo is my class name, and this is main method having print statement. First of all, we will try to run this code and see. Before even running it, let's try to confirm that if I have Java 24 installed on my system. So how do I check version? Is Java-version. You can see that I have Java 24 installed. Now let's run the code and see. I'll be using command line to compile and run Java codes. Java C, and what is the class name? Java 24 features demo.java. This is my fully qualified class name. Let's compile it. This code compiled successfully, and let's run this code. How do you run it? Java. It will say that because you need backslashes when you run with Java command. So when you use IntelliJ or Eclipse, you need not do all this thing, right? So the dot was the problem. So I'm giving the fully qualified class file name. Yeah, our first Java 24 code has run successfully. Let's talk about this feature, simple source files and instance main method. In this feature, Java has lifted the restriction of main method being static. So you can have instance main methods. So this is a class, and what do you mean by instance method? It is not a static method, right? And let's see if this code works. So if I do Java C, it compiled it correctly. Now I'm just running this. So what it says is main method not defined in class this. Please define the main method as public static void main. Now why is this? The reason being that this is nothing but a preview language feature for fourth time. It was first introduced in Java 21, but it is still a preview feature. What does that mean? Are you not aware of what preview feature is? Let me tell you. Preview feature is any language or JVM feature. Those are almost ready but still being tested and not finalized yet. This having instance main method, it is a preview feature. It is not finalized yet. It is in the testing phase. You need to compile and run the code having preview features by enabling the preview feature flag, and we need to do exactly that in order to avoid this error. So let's do that. And second argument you need to provide is release. So our release version is 24 followed by the class name that you want to run. So compiler will now understand that we need to enable a preview feature is present in Java 24. Let's compile it. Yes, it has got compiled successfully. We need to see if it runs now. So even while running, you need to enable the preview. This time you need not provide release option. Let's see if this works. Yes, it worked. And now you don't see this kind of error because preview is enabled now. That's good. We understood how to compile and run preview features. So this feature was originally introduced in JDK 21 as a preview feature. It continued in Java 22 and Java 23 as a preview feature, and this is the fourth time in Java 24 it has kept as a preview feature, which is almost finalized. So it is very important to know. And why is it useful? This makes Java more beginner friendly and aligns with modern scripting style execution. In the first feature demo, we used Visual Studio Code as IDE and we ran our code through command prompt. So we learned how to try out preview features using command line. Now we will switch back to IntelliJ IDEA, our favorite code editor for Java and Kotlin, for further demos. The second feature that we are going to explore is
primitive types in patterns, instance of, and switch, which is covered under JDK Enhancement Proposal 480. Java 24 makes pattern matching more powerful and expressive. This is a preview language feature. It enhances pattern matching by allowing primitive types in all pattern contexts and extend instance of and switch to work with all primitive types. I love this feature and you will shortly know why. A quick note on pattern matching. If you are not aware of it or might have forgotten it, let me remind you what is pattern matching in Java. Pattern matching involves testing whether an object has a particular structure, then extracting data from that object if it's match. Confusing? Let's try it out and understand. Just to show you the settings that I have done, go to project structure, and in the project you can see my project has SDK 24 in order to compile and run the code. So that's fine. Coming back to pattern matching, in order to understand this feature, let's write a quick code. So we know that object is parent to all the classes. So what I'm doing, I'm declaring a reference of type object and storing an integer value into it. Now if I'm just trying to do some integral operation on value, like I'm trying to just multiply it by 2, what will happen is it will throw a compile time error. Multiplication operator cannot be applied on object and integer. These both types are different. You can't apply this operation. So this will result into error. So what is an option? So in order to resolve it, I need to at least typecast that value into integer and then apply multiplication, and this will run, right? So just running this. So here we are not applying pattern matching. This is simple typecasting that we are applying here. There is another smart option which is provided over here. So what I want to check is value is instance of. I'm using instance of operator. It checks the object structure, and I'm checking if the object structure is of type integer. Followed by this, you can just give a variable name, for example I. Okay, so what will happen if the object is of type integer? It will create a new variable I, and it will automatically do this typecasting and assign that value to the variable. Try that out. Let's run it and see ourselves. I can simply print I, or even I into 2. That is the operation we were trying to do, right? So I into 2 is equal to this. Fine. Let's try to run this and see if this I really holds value which is typecasted into an integer. Okay. Again, I'm running the code. Bingo, you understood what is pattern matching, right? Now we will understand what the feature is. So till Java 23, you have to use box type. So this integer is a box type and int is a primitive type. Until Java 23, matching to a primitive type was not allowed. So in Java 24, this has been introduced as a feature. So you can basically provide a primitive type over here. See, and it will still give the same output. So yeah, and that is the feature that I wanted to demonstrate here. I'll just comment this code out. You understood what I wanted to show you. What is pattern matching? What we can do is we can also try switch statement, because pattern matching is not only supporting instance of, it is also supporting switch, it is also supporting record types. Okay, so it will be interesting to see that. What I've done is I've created a record type as book, okay, which is having 3 member variables: name, author, and pages. If you are not aware of record, it is just shorthand expression to declare a class, but it automatically generates getters, setters, and toString. This is called as header of record, and in header of record, this is also providing you a constructor of that class book. These parameters in the header will automatically become members of that particular class. You will have get name, set name, get author, set author, then get pages, set pages. Then it will have equals and hash code methods overridden automatically, and it will also have toString method for this particular record book. Okay, so this one line is covering a lot of boilerplate code. Well, so I have created a simple record type, and we will also see how pattern matching works with records. So this is just one value we tested. What I'll do is I'll create array of multiple objects, and we will test with multiple objects, right? So let me create that object array first. Object array. So test values these are my test values, and I'll use array literal notation in order to show. So first value is integer, let's say 10. Second value is double, let's say 11.11. Third value is, let's take a string, hello. And fourth value is my record, okay, record book. We saw that record is a shorthand notation to the class, so you will create the object in the similar way. There is no change in how you create an object. So name of the book is book 1, name of the author is author 1, and number of pages, let's say 299 pages. And yeah, so we have couple of test values. Now let me just loop over and call the method that I have written for pattern matching demo, and it takes one object at a time. It processes that object, and we will see how we can write pattern matching using instance of, pattern matching using switch over here. So the ground is set. We will just iterate through these test values. Let's use this notation. So object value from test values, yes, and one by one let's give a call to pattern matching demo. Okay, just let's print this particular line so that your output is readable. So we have just called this particular method pattern matching demo with multiple inputs. Now let's write a code for it. So part of the code we already saw, instance of with primitive values. So if value is instance of, we have integral type. So if it is int, this is a primitive type, and we already saw this part of code earlier. So if that is so, just print out. Second value we sent was of type double, right? So let's do that using else if value is instance of double d, and we are going to do the same thing. Just detected value is of type double, so this created another variable and we are just printing it. Similar thing will be for of type string. This is not a primitive value, this is a reference value, but it is fine. It was already supported in Java 23 as well. Now the next type is record. So I want to see if it is book, value is of type book, and I'm just printing that out. So the codes already give you toString method, so toString will be invoked on this particular book. So let's check out this part of code where all the values will be tested against this if-else statements, and let's see the pattern matching happening over here. So these two cases are pattern matching with primitive types, which is introduced in Java 24, and this is also supported in Java 24, but these reference types were already supported in Java 23 as well. So let's run the code and see the output. Let me maximize the output screen, and you can see processing value 10. The detected value is of type integer, int, primitive int 10. Processing value 11.11, it is double. Hello, it is of type string, and book is of type book. So this is good. We understood how pattern matching works in case of instance of and in case of records as well. So what we haven't seen, so this part is also done here. So I'm just moving this comment up. So what is left is we can also have a switch statement do the same thing for us. So switch is also supporting primitive types, switch of values, case, int I, and now you have, okay, I know why is the problem, because there is no default branch. It is saying it should cover all the possible values. We will do that, don't worry. So pattern matching switch statements were already introduced even in the previous version of Java. Let me copy and paste the same thing and say t double, then guess, string s, we'll say string. Let's see if the record is supported. And bingo, it is supported. It seems like so. And the default branch will be unknown type, and just printing that value out here. Yeah, it looks good. Now let's try to run this code. Okay, our code is executed. This is result of instance of operator, and this is result of switch detected type int, switch detected type double, switch detected type string, and switch detected type record, right? So this is good. Let me tell you one more scenario. So if you have multiple line of code you need to write against the case statement, the way you need to do is like this. That is one more tip I had to provide you about pattern matching in Java. You can observe that IntelliJ internally enabling the preview in order to run this type of code. If it does not enable preview, this code will not run, as we have seen earlier. So some history about this feature. This was originally proposed under JDK enhancement proposal for 55 and delivered as part of preview feature in JDK 23. So that is great enhancement added to Java 24, and I personally like this so much. This is so useful. We basically got smart typecasting feature in Java as well. I have already used such kind of feature in Kotlin, but now Java also has a smart casting feature. That is a good news for Java developers. And this is still preview feature. This is not finalized yet. It may improve or get finalized in the next version of Java. I'll cover that too, don't worry. The third feature that we are going to see is flexible constructor bodies. It is a third preview and it is covered under JDK enhancement proposal 492. It is a major enhancement in Java 24, allowing running a code block called as prologue before super or this constructor invocations. Earlier, it was not allowed to have any code block before super and this constructor invocation. We are going to see the demo of it, so don't worry. Let me create a separate class called as person. Well, I'll just replace. I have just written some basic boilerplate code which I don't want to repeat. Okay, it is not a record. It is not a record. So I have a simple class with two member variables. There is a parameterized constructor. There is a default constructor, and this is a constructor invocation. As it is this, it points to the earlier constructor invocation, and let's mark these constructors as public as well. Yeah, and shall we move it to the separate class? Yeah, no harm. Let's do that. So public class student, and we have a student which extends from person, and so to initialize person's fields, it basically invokes superclass constructor, which is nothing but a person's constructor. So if I control click here, it will go to the person's parameterized constructor. Quite straightforward, and it initializes its roll number field. So about flexible constructor bodies, you need to know the concept that till JDK 23, this super constructor invocation or this constructor invocation needed to be the first statement. No code block was allowed before this. So it had to be first constructor invocation, and following that you can have your constructor code. That was fine. But one drawback of that approach was if you have some kind of code like validation or field initialization you need to do before actually calling the super constructor or some other overloaded constructor of the same class, it was not allowed earlier. But now it is allowed. What does that mean? You can actually write any kind of block of code here. So it is this block of code before super or this constructor calls called as prologue, and whatever code after the super or this constructor call is called as epilogue. So prologue was not allowed earlier, but now it is allowed. So you can have any kind of code over here. You can even do, the validations like age should not be negative, roll number should not be negative, name should not be empty, anything like that. You can do that before actually delegating your call to another constructor. Okay, so just to demonstrate, okay, similar line, I'll copy in person. The default constructor basically calls the person, so prolog in person. Fine, let's call this out. Okay, here what we are doing is I'm giving a documentation comment. So I'm creating object of a student class. Student s is equal to new student, and we need to call it with 3 arguments, right? Name, so string, double and long, these are the 3 arguments. String abc, double 10.3 and long, so 1 2 3. Well, if I call this, it should able to run the block of code that is prolog. So this is prolog should be executed. That is my expectation. Let's go back to this, and I need not store this. We are not doing anything with it. Similarly, we have it for person, and person we need not provide any arguments, or we can have 2 arguments, and later we can have no arguments at all, right? Those are the 2 constructor overloads we have. One with 2 arguments, it assigns simply, and one with no argument, that is default constructor, which has a prolog again and call to the parameterized constructor using this. So good, let's give a call and see if it works. If this does not throw any compiler error and it runs, then our code is tested. So see, prolog in student, okay, that is a result of this. Prolog in person, which is a result of this, and this has no print statement, so it does not print anything. That's good. So flexible constructor bodies, this feature was originally introduced in JDK 22 as a preview feature, and it previewed for second time in JDK 23. It is previewed again in Java or JDK 24 as well without significant change. So there are no significant changes, but still it is getting previewed. So key benefits of this feature is more flexible constructor logic, so no strict ordering of initialization, less redundant code, no need to move your logic for after super, right? And more intuitive and developer friendly. Next feature that we are going to see is stream gatherers. So Java streams are favorite for Java developers, but they are always been missing one piece, an easy way to do custom intermediate operation. We had limited number of intermediate operations. There was no way we can write our own custom intermediate operation itself. So here enter stream gatherer, which is going to be a game changer. So stream gatherer API has been introduced to support custom intermediate operations. This will allow stream pipelines to transform data in ways that are not easily achievable with the existing built-in intermediate operations. We are going to see a quick demo of this stream.gather, but we will not cover it in details because it will be time consuming. So just comment in case you're interested to see another video dedicated on stream gatherer API. Let's create another public static void function. Also, what I'll do is I'll just move this flexible constructor bodies code over here. You can simply have a call to this. We will create a stream of finite number of integers. Let's create a stream, and I have a gather method now. So gatherer is another stateful intermediate operation, and it is also an extension point. I'll not put a lot of discussion on what is an extension point, but it basically provides you way to provide a custom intermediate operation by providing a gatherer. And what is gatherer? Gatherer is basically an interface which works with 3 type arguments. T is type of the input elements to the gatherer operation. A is potentially mutable state, so you maintain state that you want to work with in the intermediate operation, and R is again the return type. So the type of output elements from the gatherer operation, and there are few functions like initializer function, integrator function, combiner function. You can have a finisher function, and you have and then to chain other gatherers as well. So let's take an example of one of the gatherers. So there is a gatherers class as well. Gatherers is a class in java.util.stream, and it provides fold, scan, map current, window fixed, and window sliding. So these are two simple operations which I'm going to show you. So let's say window fixed, and you need to provide window size over here. So for example 3, and I'll just do to list for each. It will provide me list of all the windows, and I'm going to print this window out. At a time I'll get a single window, so I'm printing that window, and you can also provide a method reference. And let's try running this and let's see what gets printed. So I'll just print one more thing here. I'm just running the code and let's see. It has created windows of 3 elements each of fixed size. So the size we have given is 3. So it created windows of 3 elements, and the last window has only 2 elements. I'll just copy the same thing and I'll show you one more gatherer operation. Window sliding. Window sliding of 3. Now, what is window sliding? So let's just run it and see what happens, and I'll explain what window sliding means. Stream gatherer demo, gatherers.window sliding, and just observe the output. 1 2 3, then 2 3 4, 3 4 5, 4 5 6. So it slides window by 1. So first window is this, second window is this, third window is this, right? It excludes the very first and takes the next 2 in the window, and so on. This operation is performed, and this is how the output is. So you can imagine how much code you need to write in case you want to write it in Java 8 or with earlier intermediate operations. It was difficult. This is possible because these gatherers also maintain intermediate state and operate on that state. It has initializer function, it has gatherer function, it has combiner function, and it has a downstream as well. So that is a power of this feature, stream gatherers. It is a preview feature in Java 24, and I hope there will be so much coming in Java streams, and it will be more efficient since it processes elements on fly. That's all about the demos, but there are few notable features which we are going to talk about. There is a language feature covered under JEP 494, module import declarations. It is a second preview, and it helps developer improve productivity by enabling them to quickly and easily import all the packages exported by a module without requiring the importing code to be in a module itself. Then there is a library feature for class file API, which helps developers improve productivity by providing a standard API for parsing, gathering, and transforming Java class files and tracking the class file format defined by the JVM specification. The next library feature is scope values, which is a fourth preview covered under JEP 487. It helps developer increase the ease of use, comprehensibility, performance, and robustness of their projects by enabling the sharing of immutable data within and across threads. So it is very much useful for virtual threads. It is a good alternative to thread locals if you have used them. Then comes a structured concurrency. It is a fourth preview, and it is under Java enhancement, JDK enhancement proposal 499. It helps developer improve maintainability, readability, observability of multi-threaded code by specifying concurrent programming via new API for structured concurrency. So there is new API introduced for structured concurrency. Then there are some security libraries which are introduced, like key derivation function API, quantum resistant module, lattice-based digital signature algorithm, and there is a lattice-based key encapsulation mechanism. So encapsulation and digital signature related algorithms APIs are added. Compact object headers. These all JEP's JDK enhancement proposals are related to performance and runtime updates. So compact object headers, it is experimental, meaning they may remove this as well. This is not fixed. This is not preview, this is experimental. They have reduced size of object headers in the hotspot JVM between 96 to 128 bits down to 64 bits. So this helps reduce the heap space. Lead barrier extension for G1, that is garbage collector barrier, for better garbage collection algorithm. This has been provided. Then ahead of time class loading and linking, again for productivity and improve startup time. Then ZGC, that is Z garbage collector, that was introduced earlier, and they are removing it from Java 24. So see, it was an experimental feature, and they realized that this is not that useful. They're removing it from JDK 24. Then synchronize virtual threads without pinning. These all 24 features included in JDK 24. I hope you liked this video and you have learned from it. So Java 24 brings some amazing improvements, from pattern matching, stream gatherers, scope value to security and performance boost. There is a lot to explore. Which feature excites you the most? Let me know in comments. Like, share, and check out my Java playlist for more deep dives. Bye bye until we meet again.